Hello everyone, this is lab 3.2.1.6 from the course Big Data and Analytics from Cisco, and this lab also is about how to clean, process and visualize the data. Here we are going to work in a dataset called RPI Data Compact, which is also, can see it here, if you realize, and then this is this one here. And what we are going to use, of course, we are going to use pandas and matplotlib. So what is the difference in this lab is that this dataset or this file has many bad entries. For example, here we will see that none, which is that this type of data cannot be processed in pandas, and it causes many problems. Alright, so first of all, why we need to clean the data. There are garbage in the data and like it doesn't apply. However, the short story that you need to clean the data before you process it. Okay, how to clean the data? First, before cleaning the data, we need to import the data, right? So first we need to import the modules and then we import the data. So to import the data here, we need to specify the path to the data that we need to import. So here we need pd for pandas, and then we need to call the function read csv, and then between the parentheses we can give path to the data, which is actually under this directory there is a folder called data, and under data we have the file called rpi underscore compact.csv. Okay, then after that let's check if the reading process happened correctly. So let's try to read from here whatever we want. So for example 3 lines. Here we have an error. It says that, as you can see, that this file does not exist. So let's make sure of the name of the file. So rabi underscore data compact. So let's take it from here and just paste it here. Okay, let's check one more time. Now we have the data correctly imported, and as you can see, for the first thing here that we have here about data unnamed something here that we don't need it, then we need to drop this column from the data that we are dealing with, and to do this we can use the drop function. So here we have the name df compact, and then we need to specify drop. And what we need to drop, actually we need to drop the column called unnamed 0, and of course we need to also specify that is it a column or it is a row. So it's column and this is going to be 1, and we need to specify in a place that in the same file we need, or in the same data frame we need to have this action, so we drop it from the same file. If you don't do this, there it will be there, it won't be deleted. Okay, so here we have df underscore, and here now again we have in place to this. This one here again, and it says that okay, there is a problem here. So let's okay, now let's check df compact again. Okay, the name here is not existed, as you can see that unnamed is not there. Yes, because we already dropped it, so let's take it from here. we cannot run this 2 times because we dropped it at the first time. So if we come here, or let's insert below and just try this, it should work. As you can see, the first column, the unnamed, is dropped already, so that was the problem here. That is not exist anymore, so we cannot run the game one more time. However, now let's remove the nuns from it. Alright, so to do this, in pandas we can search for any function we can reach or learn about it. So if you go to this link, which is about pandas this documentation, and you go down here and type is null, then you will get a description, but we don't need to do this because this code is covered everything. So actually what is happening here, that this function or this method, or actually that when you call this method here in the data frame, is going to contain true or false. So if the corresponding element in the data frame is none or not. So if it is none, then it's going to return true. If it is not, then we are going to return false. And using the function called sum on this data frame will automatically convert all the truths into 1. Then let's return back here and check the output. So if I am going to apply the is none, since this is null to the TF compact, then this is not none, then it's going to return false. If there is a none, then it's going to return true. And there is also a function here that is going to count the number of ones, which is called sum. So we can calculate the number of nuns in the data frame. So as you can see here now, one more time false, it means that it was not none. Okay, so we served the output, or we saved the output in nuns in the data frame, and then we have this new data frame called nuns in data frame. Then when we apply the sum in this data frame, it's going to convert the true to 1, and then we will find the number of nuns there. So if we click here, so you will find there that in the pink column there is 1 none, in the download column there is 1 none, in the upload there is 7 nuns, in the date there are 7 nuns, and the time there are 7 nuns. If you apply again to the this sum to the total one more time, so actually what you have here, you have none per column, and when you apply none per columns again, then you will have the summation. Alright, so let's repeat again one more time this process here. We have a function or a method called isNone. It returns that the value is true if it was a none in the data frame, and we return the output in a new data frame called none in df. Okay, now none in df, we can use another function called sum to convert or to count how many number of nuns in each column. So at the end we will have one data frame in this format, and it returns the number of nuns in each column. Alright, then if you apply the sum one more time, then you will count the number of nuns on this. So on the result of this, we can have 23, which is 7, 7, 7, 21, and plus 2, then 23 nuns in the data frame. But now we don't know exactly the positions, where in which column, in which row in this position, and actually we don't care. So to repeat this process again, so we can apply for the same data frame as null and then 2 times sum. So we will have the same output here, 23. Hopefully it's clear here what is happening. Okay, so we have a data frame, we apply is none. This is none, returning a data frame where true only if there is a none in the data frame. And when we have sum, it's going to change the true into 1. And then when we have sum again, then we will count the total number of nuns in the data frame itself. Okay, now in the next step we will use pandas function to drop none. This is a function to remove none from the df compact. Alright, this data frame. So this is the new data frame here, and then we are going to use numpy or np to round, and then we apply the function sum here is going to be 23, and then you know the percentage of it, so the total number of like the length of the rows and the length of the columns, multiply by them by 100, and we need to specify only 4 digits after this, and then we print the value, and here none total, which is going to be 23, and none PCT, which is here like number of missing value percentage to the total value. So it's going to be here, this is the value here, none is 23, and this is 0.6% of the measurement. Okay, and this is a good, not a high value, so the data is acceptable and we can process the data. Okay, to remove all the nones, there is only one function it can be used, and this is drop none, and then let's run this one, and here let's compare the length of the new value with the old value, and then we can find how many rows or columns we lost. Okay, so to do this we just specify, for example, print, and then we put here the length of the df compact. This is the original one with the nonce, and the second one print again length with df compact clean. Okay, let's run them. Then the original was 680, and new one, or the clean one, is 673. So from there we can realize, or we can conclude that there were 7 rows with nones, and then in these 7 rows there are 23 nones, but we don't know exactly how many or like there. So as a conclusion, we have dropped 7 rows, and this means that there were rows with more than 1 nones. Okay, now let's change values format. Okay, so let's now try to do something here, and now we do the type of the df compact. So actually it's here. So when we click here, so we will expect, okay, df compact one more time. So let's check here the head, and here as you can see we have ping, we have download, we have upload, we have date, we have time. So as you can see here, that you can think that okay, it's ping, it's a float, and this is also float, and this is also float, and this is date, but it's not like this. You always have to change the format of each column. So if you check now the format of the ping, it's an object, it's not a float. If you check the format of the download, it's also object. If you check the format of the upload, it's a float. If you check the time and the date, they are also objects. So now we would like to change or do typecasting. So we change the value of one of the strings into or one of the object into float. So to do this, we can use the float function, and we already learned about this in part 1 from this course. Okay, now let's convert the values from the columns ping and the download using the lambda and apply function. Alright, so what we actually are going to use, we are going to use a lambda function, and with apply, to apply the lambda function on all the columns that we would like to change, and in this case we have ping and we have download. Alright, so let's do this, and here there is only like a disable notebook. This is a warning that we don't need to have it, and it's not relevant to this course or to this lab. So because you change the value from string to float, it's going to tell you be careful or warning. So however, you can disable it using this line. So PD option mode chained assignment none, and as you can see, this disables the notebook warning that is not relevant for us for our use case. Okay, so now I am going to reach to create a new column. The new column is going to call pinks ms float. The content of this column is going to be from the df compact, of course the new one, which is a clean. The old one we don't need to use it anymore because it has nonce values. And then we need to have from a column called pink ms. Okay, so and we need to apply for this column a lambda function, and this lambda is going to have one parameter called value, and it returns a float for this value. Okay, so what we have here, we have a pink column. We are going to create a new column called pink float, and the content of this one is going to take this value as a lambda function and returns the float value of this lambda function. Alright, in the same process we can do the same with the second column. So we are going to create a new column called download megabit per second, and the content of this column is going to take the old value from this one and apply the lambda function, and it returns back the float value to this new column. Okay, then let's check the type of the new table. So let's do this, and here we need to specify that data type or data types. Okay, so let's run. And as you can see here now, I have a pink, the original one object, and I have a pink new column called pink ms float, and I have downloaded float. They are floats here. Okay, so what about if I would like to have the head? So I have to see new columns, and this is the new column here, the first one, and this is the new column here also. Now next step, we need to drop the old columns. We don't need them anymore, right? So because we modified the new columns, then we need to delete the old columns. So to do this, we can refer to the df again compact, and then we have here clean. Then we need to drop the pink and we also on the same line we need to drop the download megabit per seconds. And as you already also know, we need to specify the axis equals 1 and in place equals true. So here we have underscore, and then we need to have this like this. So pink, we drop this, and we also drop this one. And the x-axis. Okay, then we need to rename the new pink float, and so we need to rename this and this to the new values here, so we can use this code. So first we are going to make a dictionary. The first one is going to be like this is the old value, the old one and the new one, and then the second one and the new one, and then you can type rename columns in a place, or you can do the basic format, so you can do it by one by one. So you can like simply do the process like this. You copy paste it here and repeat 2 times, but just to make it more to look more professional, then you create a dictionary. You specify the old one, and then the new one, and then you specify the old one and the new one, and then you use the rename method, and then you specify the columns is going to be the new columns, and then place again true. Let's run this one, and here df compact is not defined, so let's take this one because the name here is written not in a correct way. Here, let's run it again, and here we have done with this. Let's check the output, and here we have the new data frame, and again it's nice to put this one and the last one because the original data frame was date, time, ping, and download. Then we can re-index the data frame. So here we have the data frame clean, and then we index, and then the columns we put date at the first one, we put time the second one, ping third one, and so on. And then let's do it again, and here we have the new data frame here. Okay, now what we have done? We have changed the flow, the ping and the upload and download to be float values. Okay, now after that we like that the dataset is finally clean. We need to store the CSV file and rename it. So as you can see, to CSV, this is the method to save to a file, and this is the name of the file, and the index is false. We don't need to have the index with this, and then we like have this df compact clean to df clean, and that's it. Okay, so if I'm going here, I have to see a file called RPI data processed. Okay, this is the file just generated now. Alright, let's return back and let's keep going. Now I can deal with the data frame clean as the data frame that I would like to process. First, it is empty, it does not have any non-value, and it's arranged in the way that I want. Okay, to do basic statistics, actually, like we can use many functions or methods supported with pandas. The first one is mean, like std, and you probably already know some of them from the previous video that I talked about them, and we covered also many of them, and also finally we use the describe method. However, now let's just follow the instructions in this lab and let's try to do the as needed. So first we need to find the mean for the columns. So then in this case we can specify df clean. This is the name of the data frame that we are working on, and then we specify the mean, and here is the first one, and we can also use the FTD or standard deviation, and here we have FTD. Okay, then let's place the mean and the STD for each column in a tuple. This is the place here, so you know that the each, now let's explain this in this way. Df clean dot head. Here we have these values. So what we need to do, we need to have the ping ping ms, and then in the next one we should put the means of this one. So for the status for ping, we will have the ping, which is the value of this mean, and the next one is the value of the ping in millisecond. Okay, so we will have the means and we will have the standard deviation for the ping. We will have also for another tuple the means and the standard deviation. So for each column we will have the means and the standard deviation in a tuple format. Okay, and then we print them out. So to print them, so actually here is going to be something like this. And here is a value for a mean, and there is a value for ping, and here is a value or also ping, but here is STD, standard deviation, and here is the standard, or here is the mean. And the same here for the download and for the upload. Now let's print them and using the format. So we can access the average ping time is this one. We can access the tuple using specifying the index. And then the second one is the position one, so 0, 1. And also you can do, instead of writing them 0, 1, you can just put that star asterisk at the beginning, then it will go through each one of them, or you just can specify it in this format. Here you put 0, the original one, and then you put comma, and then you specify this one, and then you put 1 here. Or, as I mentioned, you can use asterisks, and then it will go through each of them. So in the format is going to be automatically the first one here, and the second one is going to be here. Okay, let's print the value, and we can see now the average, the mean for each column, and the STD for each column. Okay, now we can also do the same and calculate the maximum and the minimum for them, and repeat the same process here. Let's run this code here, the same what we have done before, and we also can use the method called describe, and here we will have a table or a data frame containing that count for the ping, download, and the upload, and we have the mean, STD, and so on. We covered this and we talked about this in the previous video. Alright, now also we can use argument minimum, argument maximum, and I location. Okay, so this is a new, now let's go through it and try to understand it. Now let's assume you would like to have a computer script that automatically emails status report to your internet provider. The reports would have to include the date and the time corresponding to the minimum internet speed. Okay, the temporal information would allow the internet provider to accurately identify the cause behind the slow connection you observed. So we can this task can be achieved using the pandas argument minimum and argument maximum function, and here we find the days and the times corresponding to the longest and shortest ping time, the lowest and highest data speed, and the lowest and the highest upload speed. Alright, so with this one is similar to the minimum, but we can use argument minimum. This is the minimum ping speed, and this is the maximum for the ping. On the same, we will get the maximum and the minimum for the download, and the same for maximum and minimum for the upload. So if you are questioning why we have minimum and why we have maximum, because the output. Okay, so let's check this more. Now let's insert the cell below, and now let's find the type of this, or what is this one actually. Let's do this one here. Now let's run this one, and as you can see that this is the value of this, and let's check the type of this variable, and as you can see it's a numpy integer. Alright, so now if we would like, for example, to have a data frame, now we are going to explain what is the how to use the argument or minimum max. So we are going to have a data frame, and the data frame is going to be now for field 1, 0, 1, field 2, 0, 2, and print the head. As you can see the data frame here for field 1, 0, 1, field 2, 0, 2. Okay, so to access the location of field 1, so if we have here I location 1 for field 1, then the output is going to be 1. So because now we specify the I location for 1, then 0, 1, so this one for field 1, then we have here, if we have here for example 0 for field 2, then we will have 0 as an output. Okay, so now use the indices compute using argument and minimum, oh sorry, argmax and argminimum in combination with allocation to visualize the data and the time of the maximum and minimum ping download and upload speed. Alright, so here we are going to print the measurement speed, and this first have the data clean to know what we are going to work. So we have clean and then dot head. Here we have the data. So the first one, we need to print the corresponding date at time. So for the first one, we print measure reach minimum and maximum. So here we need to find the minimum and the maximum for each of them. Okay, so here we have location, and the location is going to be argument minimum ping. So this is the location of it, and we also specify the dot date, and we specify the maximum again for so argument min ping dot time. Okay, so what we have done here, so we specify the location of argument minimum for the date, and the argument minimum we specify the time. So it's going to go there, and minimum value is going to be repeated we found, and then we will reach the time, and then we will reach the date. Okay, for the same we will do for the upload and for the download. Then we have to close this one. Here we have the argument minimum, so we do the same for the remaining lines. So here for the download speed, we specify for the download argument minimum speed the download, the date, and the time, and for the also for the upload, and then we have the maximum for all of them. Okay, so let's print them here. All right. So one more time, if we go back here, we have the argument minimum and maximum. So we will have the location of them, and then we will specify like from the argument the minimum value, let's assume this one, and then we will have the location. From this one we will print the corresponding date and time. Alright, now let's create a correlation, and for the correlation here we will have like we covered this in the previous video, we have the correlation or core method that we can specify it here, and there we have the correlation for the three of them, the ping and the download and the upload. And as you can see here, like the download, the correlation between the download and the ping is minus 0.0, and the upload on the ping is minus 0.4. Alright, so let's now print them here, and here you can see the correlation between ping and the download, and the correlation between ping and upload, and upload and download. Okay, what we also can like you can read it in this way, but if you would like to print it in a professional way, then you can use again the format, and you specify now using the location. So if you have to ping with ping, then you could specify 0, 0, but this is not necessary because it's always 1, because when you make correlation with itself, with a variable with itself. So ping with download, so it's 0, 1, and then ping with upload is 0, 2, and then you need download like upload and download, so it's going to be 2, 1. Okay, so this is the location here between the upload and the download. So this one is needed. Alright, so this is the output here, and the last part we need to visualize everything. This is the important step. So to visualize again, we have to use the matplot. We import the matplot as PLT, and then we need them to be in line. Here we will plot based on time. So first we have to generate subplots. So here we have figure and axis. You will have this figure to generate this shape here, and then you specify for the axis is going to be plot and the figure size is going to be 10 and 5. Then you can put 10 and 10, then you will have a square format, but let's keep it 5 as recommended. Alright, let's return back and then you put here. Now we are going to put something on the x-axis. For the x-axis, what we need to specify the time from the data frame that we have here. Okay, let's do this search cell above, and then again df clean it. Okay, so the x-axis is going to be the time. So that's why the time is mentioned in the t and then variable, and then we will put the t on the x-axis. So for the plot 3 curves for different colors. So for the A plot for the t, the time axis, and the first one is we put the pink. The second one we have to put the download, and the third one we have to put the upload. So here we need to specify the download, and remember we converted this to float to be able to draw it. Otherwise, if it's object, then you will not be able to draw the output here, and here it's going to be label like download megabit per second. Here in the last one we have here the upload. Okay, so here we have the download, and they're all of them with the and refers to the time. Okay, then we have the legend when we can specify what we need and then figure show. Okay, what is needed here is to like put the name of the figure or things like this are related to the label. So if we run this one, here we have a problem, says that as is not defined. So here we have AX, not. Okay, let's run this one, and now you can see now we have this figure. If we skip this one, then we run it, then we will not have the legend here, the figure, small figure here to specify, like telling us which curve is for what. Alright, next let's change to the line style. So what we also need to do that we can change the line style here, and we can with pandas we can use also this. So as it's mentioned here, because being measurement include a large abrupt variation, then the perhaps better visualization using dots. Alright, so let's take this one from here, and then we put it here because we won't convert anything, and just the pink is going to be in a format of a line style dot. So to do this we can specify O for a dot, and then the label is this one. You can also put specify red or green or the color, but it's not needed, so we just do it like this. Here, as you can see now, I have the line style changed to something like this again, and now let's add axis labels. So we have the same output here. So for the axis, now we can specify that what labels do we have or we need. For example, here we need to add some text, and here is text, and here is also a text. So we can do this also using the set x label. And here for the x label, let's add like um, something like this, and here is going to be time. This is for X table, and it is mentioned in our minute and second. And then we specify the size. It's going to be, for example, 16 as is needed there. And here we close the line here. So time is going to be something like this. And the size is 16. Let's take this one again. And here we have again x-axis, and now we have the y label. So for the y label we need to specify that the measurement. And the last one, which is the title, let's assume that it's going to be internet speed as it's mentioned, or just put here whatever you want. So big data. And here the size is going to be 18. Okay. And then we specify that the size to be 14. Let's do this figure first. And here you can see big data we have here and the measurement, and there is here. And now let's make the text size for 10. And as you can see now here more, we can also put uh, 1, and let's run it again. And you can see it's very small. Then you can put it here 14. Now you can see it's bigger. Alright, now let's change the plot theme. We can do the same, like you can see now the background is white, but we can use a style called 530 style. We can read about it here. This is 530 style, and this is the source code, and then we can start with this format, and we can specify it like only with the style. We specify the style in this format, but here make the previous graph more visually appealing. To do this, add the row width statement to your code. So okay, so let's put the same code. So with plt.style, this is the one, and then we continue the code from here. This is just as before. Let's run it. Okay, so here is the problem. Here we have context. Okay, so here we have the figure now with the style, and then we could specify this with the context. Okay, so we can read about it more from here. However, so just we put with at the beginning, as it's mentioned here, to your code before calling the matplot function. All right. What also we can generate? We can generate histograms. With the histograms, you know, now we are going to have 3 histograms. The first one is as position 0, 0, the second one as position 0, 1, and the third one and 1, 0. So we will see 3 histograms, one here, the second one here, and the third one here. So in the first one, we are going to put the, so first we generate the figures. So the figures we have actually 2 subplots, and each size of them is 10. So here is an array we will have, and for the first one is 0, 0 for the position, and then we will put the clean, use the df clean, and then we specify the bing, and then we specify mpins, and then we set the label, and then we set the take parameter. For the same, we repeat for the upload and for the download. So if we run here, we should see the histograms. So here we have 2 2, so it's an array of 0 0 0 0 1 1 0. It should be here 1 1, but we only have 3 figures and this one left empty as is needed. Okay, that's all for this video, and thank you, and please do the lab by yourself and feel free to ask in the lab anytime.